Ken Ono is the idol of many math students. Hong notes when discussing her decision to hire her former teacher. Ken Ono has spent decades at the peak of academia as a mathematics genius. He used to be a tenured professor in mathematics at the University of Virginia with a resume that read like a collection of impossible achievements. He is the man who translated the work of self-taught genius Srinivasa Ramanujan into modern proofs. Ono was the vice president of the American Mathematical Society from 2018 to 2021. He has been a mathematics consultant for Olympic swimmers and Hollywood directors. Ono made a choice that feels like an improbable one, even for someone who has ventured as far and wide as someone like him. At 57, he is walking away from his life at the University of Virginia, is trading his security for a startup in Silicon Valley. He is leaving to work for a 24-year-old woman who used to be his student and is herself a math prodigy. Ono is famous for his work in number theory. He specializes in the strange world of integer partitions and the hidden structures that govern how we sum numbers. He took the mysterious patterns first noticed by Ramanujan a century ago and proved they were part of a larger framework. He discovered the rules that make these patterns predictable. This work earned him major fellowships and a stature as a math legend. Now he is taking an extended leave from academia with no plans to return. He's jumping to a company founded by one of his former students, Carina Hong. Carina Hong is not a typical 24-year-old. She is the kind of talent that makes even the most accomplished people feel a bit sluggish. She finished her undergraduate degree at MIT in 3 years. She won the Morgan Prize, which is the highest honor for an undergraduate math researcher in the United States. She was a Rhodes Scholar. She was pursuing a joint degree in law and mathematics at Stanford when she decided that the path was too slow. She dropped out to start Axiom Math. Hong has raised $64 million to build the first truly capable machine mathematician. She is going after the best minds at Meta and other tech giants. She is recruiting people who are already pioneers in the field, and then she is going to her mentor. She comes with a background that is rooted in the high-pressure world of math competitions. She grew up in China and taught herself English just so she could read advanced textbooks that were not available in her native language. She spent her youth solving problems under tight time constraints in Olympiad programs. But she eventually found those hits of dopamine to be insufficient. I was always very interested in mathematical discoveries. Olympiad math is a constant dopamine hit, but research math is banging your head against the wall. It's pain and suffering. I like that part. Hong explained to the Wall Street Journal. Hong likes the struggle at the intersection of law and math. She views both fields as systems of logic that require a specific kind of rigor. But she sees an opportunity to bring them together in a way that no one else is doing. During her morning runs around the Stanford campus, she thought about the advice to run toward the hardest problems. She decided that while researching math is hard, building a machine that can do research math is significantly harder. That is the challenge she cannot ignore. She was spending her weekends in a coffee shop near campus, where she met a scientist from Meta. They sat at a communal table and realized they were both obsessed with the same thing. They wanted to know if a machine can ever truly understand a proof rather than just predicting the next word in a sequence. They talk about how to combine the raw power of large language models with the logical consistency of formal verification. Out of those conversations, Axiom Math was born. We're not building another chatbot that mimics solutions. We're teaching AI to prove theorems. That's a fundamentally different challenge and one worth pursuing, Hong said to Veen Express. The company name refers to a basic truth that serves as the starting point for a theory. Hong wanted to build something that could not only solve problems but could also validate its own work. She wanted a system that could reason. It was about creating a superintelligence that could optimize logistics or verify the safety of critical software. The commercial applications were obvious to anyone who looked closely enough at the landscape. We see math as code and code as math. The real magic comes from combining AI, programming languages, and mathematics, Hong noted in an interview with Thought Economics. The ambition of the project was matched only by the speed at which Hong moved. She built a team that was a mix of young prodigies and industry veterans. She tells that their goal is nothing less than the changing of human knowledge. She knows that to succeed, she needs to bridge the gap between the abstract world of pure math and the practical world of engineering. Math is the perfect sandbox for building superintelligence, Hong told Forbes magazine. As Hong and Ono began to build their team, they realized they were entering a crowded arena. The race to create a machine that can think like a mathematician has become one of the most competitive domains in the AI vertical application. Every major player and a dozen well-funded startups are all chasing the same prize. The 2025 International Mathematical Olympiad ended with a result that signaled a shift in the hierarchy of intelligence. For decades, the competition served as a gatekeeper for the world's most talented teenagers. But in this year's contest, the machines did more than just participate. They reached the podium. Both OpenAI and Google DeepMind announced that their experimental reasoning systems scored 35 out of 42 points, a performance that met the gold medal threshold. Out of more than 600 human contestants, only about 10% earned a similar honor. The system solved 5 out of 6 problems under the same strict conditions as the students. They had no internet access and no external tools, relying entirely on the logic baked into their architectures. The former medalists who graded the proofs mentioned that they were always correct and often super clear in how they got to the answer. While 5 teenagers still managed perfect scores that the machines could not match, the gap is closing. I don't want to add to the hysteria, but in many ways these large language models are already outperforming most of our best graduate students in the world. Ono remarked in a public discussion about automation. Axiom Math will be competing against 3 main categories of players. First up are the teams who are all trying to build a system that can write a proof in a language like Lean or Isabelle, where the computer verifies every single step. It's super rigorous, but it often misses the kind of gut feeling that human mathematicians use to come up with new stuff. It's a slow, careful method, but it guarantees correctness, which is their top priority. Then there are the natural language teams. These groups are building models that can explain math in a way that humans can understand. These models are great at spitballing and finding analogies, but they often struggle with the absolute precision required for a formal proof. They can be brilliant, but they can also be wrong in very convincing ways. Axiom Math is a hybrid. They are trying to do both. They want the intuition of the natural language models and the ironclad logic of the formal verification systems. They are looking for the sweet spot. This is the hardest path because it requires a deep understanding of 2 very different disciplines, but it is also the path that leads to true superintelligence. Other startups like Harmonic are also in the hunt. The founder of that company has mentioned that the arrival of a mathematical superintelligence is getting closer by the minute. Ono felt the pressure of this race during a symposium where he was asked to curate problems to test these new models. Think of it like a map for a sailor. Before you set out to discover a new land, you need to know where you are and what's already been explored, Ono explained when discussing the importance of benchmarks for testing models. He went in feeling confident that his job was safe for decades. He came out feeling deeply shaken by what he saw. He saw models that were already beating him in areas that were not his specialty. He started spending hours every night talking to the models on his phone. The lead I had on the models was shrinking. And in areas of mathematics that were not in my wheelhouse, I felt like the models were already blowing me away, Ono admitted to the Wall Street Journal regarding the speed of technological progress. Then I had an epiphany. I realized what the models were offering was a different way of doing math. The move to Silicon Valley is a massive shift for Ono and his family. He packed up his life in Virginia and headed west with his wife and their dog. He took a position as the founding mathematician at Axiom, which was a title they negotiated after initially considering something less formal. His job is to push the models to their limits. He creates problems that can only be solved by a system that truly understands mathematical principles. He provides the map for the engineers who are building the engine. Ono insists that he did not make this move for the money. He was already one of the highest paid employees at his university, and he turned down more lucrative offers from other tech firms. He is doing this because he wants to be part of a legacy project. He wants to see if a machine can finally crack the problems that have stumped humans for hundreds of years. He wants to know if there is a deeper level of truth that only a superintelligence can reach. I have the luxury of participating in transforming how the world actually works. As a pure mathematician, that has rarely been the case, Ono says in one of his interviews about joining the startup. The offices of Axiom in Palo Alto are named after the greats like Gauss and Turing. Ono finds himself surrounded by people who are often his own age, despite the company being run by a 24-year-old. Many of the top researchers in this field are at a stage where they have the financial security to take risks on big ideas. They are looking for the one project that will define their careers. For Ono, this is that project. One thing I heard from some of the top researchers and mathematicians I've recruited to Axiom is that solving for mathematical superintelligence will be their legacy, Hong remarked to Business Insider. Even as the models get smarter, Ono believes that there will always be questions that remain unsolved. He thinks that the nature of math is so vast that there will always be a need for human intuition. But he is excited to see how far the machines can go. He wants to be there when the first AI mathematician makes a discovery that no human could have imagined. He wants to be the person who helps it get there. Machine-assisted mathematics actually promotes a diffusion of ideas between different fields, unlike humans, who are bounded by academic specializations. Hong explained in a discussion with The Neuron. As the sun sets over Palo Alto, the work at Axiom continues. The servers are humming, and the chalkboards are covered in equations. Ono and Hong are working together to build a future that is as elegant as it is powerful. They are not just making a company, they are making history. They are proving that when you combine the wisdom of experience with the energy of youth, anything is possible.